Okay, welcome to Chemical Engineering Lab. Today we'll be studying response of a first order system to some input signals. Our aim is to verify the response of the thermometer to some input signals as a first order systems, and also to determine the time constant for this system. So here we have a thermometer, a mercury in glass thermometer, and then we also have a thermocouple. So we can see that a thermocouple is digital, which measures instantaneous readings and cannot be used for this type of experiment. Meanwhile, this mercury in glass thermometer is a typical example of what we want to study, as we'll be able to see how the mercury in glass will respond, all right, to the input signals. There are various input signals that we are going to be analyzing. We have step change inputs, we have ramp input, we have impulses, and we have other inputs that you would analyze after collecting your data. The apparatus for this experiment is one, the mercury in glass thermometer. Okay, although we have this thermocouple, but we are not going to use it, just for demonstration. We also have glass beaker, and we have the hot water bath. And then basically maybe your timer to time the experiment. For carrying out this experiment is to heat up some water in the beaker. Okay, you heat it up at about 95 degrees centigrade. And then we will see the characteristics of this mercury as it rises towards the mark of 95 degrees centigrade. So we are going to take our readings at every 5 seconds. So the first reading being the room temperature at time t equals to 0 is 31 degrees. In other days you can have 25, or you can have 26, you can have 27. So that depends on the temperature of the day. Okay, but now that we have the hot weather, we are starting at 31 degrees at time t equals to 0. So now let's go. We'll now check at intervals of 5 seconds, and we'll check how the mercury rises. Okay, so you take the readings at every 5 seconds, and then you stop at 95, exactly 95 degrees. For safety reasons, you might stop at just 90, because this mercury in glass thermometer peaks at 110, and anything above that would actually destroy the thermometer. So after the heating experiment, then you come out to do the cooling experiment, which we will take the readings at every 5 seconds intervals of how this mercury drops. At the end of the experiment, during your analysis, you have to compare the characteristics of these signals, such as step change inputs, ramp, and then impulse. This will give you further knowledge of understanding how a first order system reacts, while you prepare yourself for other courses in chemical engineering, such as process control, engineering, analysis, and the likes of them. So see you in the next class.